Alright, so for y equals 2x to the fifth plus the square root of x cubed over 2 plus 5 over x minus pi, what we're going to do is we're going to do the following. We're going to find part 1 dy dx, 2 the integral of y with respect to x, and then part 3 the limit as x approaches 4 of y, and state the meaning of each result. Okay, so you execute these commands and then you state what the result means. So for part 1, we have to find, let's rewrite the function. Okay, so what I'm going to do, let me just rewrite it first. 2x to the fifth plus the square root of x to the third over 2 plus 5 over x. I'm going to try to express the terms as powers if possible. Sometimes you can, sometimes you cannot. In this case you can, that's what we're focusing on. I will express each term as a power so I can apply the power rule. Okay, so let's rewrite what we're about to do. Rewrite, this is pi, rewrite the terms as powers where possible. So we have y equals 2x to the fifth. This is already in the power format. Now the square root of x to the third can be written as a rational exponent in its power format. There is an invisible 2 here, so this can be written as, let me put the 2, this can be written as x to the power. The power becomes the numerator and the root becomes the denominator of your rational exponent. That's divided by 2 plus 5 over x can be written as a power. This x has a power of 1, so if I want to write it as a power, I will have to reciprocate. Okay? It needs to go upstairs. If I reciprocate, it becomes 5x to the what? Negative 1, right? 5x to the negative 1 minus pi is a constant. It has x to the 0th power next to it, but that's just by the way. Now that we've written everything as powers, we can go ahead and differentiate. There are two formulas that we're going to be using here. The power rule, so the derivative of x to the n. So this is equal to, you power down the power n, x to the, mark down the power by 1. And then you also have to remember that the derivative of a constant, let's write that, derivative of a constant, the rate of change of a constant is 0. Since it's a horizontal line, you keep on running but you never rise. Put the prime notation there to indicate the differentiation process. Alright, now let's go ahead and apply these rules here. I will be factoring out coefficients where applicable. So y prime, remember dy dx is the same thing as y prime. Okay, factor out the 2. So we have 2 times x to the fifth prime. And then you can factor out 1/2 plus 1/2 times x to the 3/2 prime. And then in this term right here, you factor out the 5 times x to the negative 1 prime. And then you differentiate the constant term, pi. Pi is a constant, it's not a variable. even though it's represented with a letter, it's a constant 3.14159, goes on and on and on, that irrational number. Alright, so keep that in mind. Now let's go ahead and differentiate. We're going to have y prime equals 2 times 5 power down the power, x to the mark down the power by 1, plus, next term, we're applying the power rule again, so it's going to be 1/2. If you power down 3 over 2, you multiply that by 1/2, x to the, you then mark down the power by 1. If I want to express 1 as an equivalent fraction with 2 as the denominator, 1 is equivalent to 2 over 2. And then, when I power down this negative 1, I multiply it by this positive. That becomes a minus. 1 times 5 is just 5. Negative 5. X to the mark down the power by 1. So the derivative of pi is going to be 0, so minus 0. Let's make this look pretty. So we have y prime equals 2 times 5 is 10. 10x to the 4th plus, if you multiply these two fractions, top with the top, denominator with the denominator, x to the 3/2 minus 2 over 2 is 1/2 minus 5. Negative 1 minus 1 is x to the negative 2. Okay? If we process it further, it becomes y prime equals 10x to the 4th has been simplified completely, plus 3/4 times the square root of x minus 5. Since x squared has a negative exponent, it can be reciprocated, which results in the power attaining an opposite sign. So 5 over x squared. Ladies and gentlemen, that is the derivative of the original function. Alright, so the meaning of what we have just found is as follows. Meaning, the rate of change, which can be abbreviated as ROC. The rate of change, another word for rate of change is the slope of the tangent line, or slope of the tangent line STL of y at any x value is given by the result we got, 10x to the 4th plus 3/4 root x minus 5 over x squared. Alright, so for part 2, we have to find the indefinite integral of y. We're integrating with respect to x. Okay, so the integral of y dx is equal to the integral of, let me rewrite what y is. I'm going to write it up here. So the original problem that we had was y equals 2x to the 5th plus the x cubed over 2 plus 5 over x minus pi. So that was the original problem. So what I'm going to do is I'm going to write down the entire integrand first. So we're integrating this expression right here, 2x to the 5th plus the square root of x to the 3rd over 2 plus 5 over x minus pi dx. Okay? Since you have a sum and difference of terms, just like differentiation, you can integrate them individually, the individual terms of your polynomial expression. So I'm going to write this as factor out the 2, the integral of x to the 5th dx, plus, I can write this as a power, factor out the 1/2, x, the square root of x to the 3rd as a rational exponent is x to the 3/2, as indicated earlier, plus 5/x is 5 times 1/x, right? So I'll factor out the 5, and I'll write this as the integral of 1/x dx, and then I'll integrate pi dx. So let's write down the two formulas we're going to be using. Actually, there are 3 of them that we'll be using for this. So we have the integral of x to the n dx. The power rule is given by x to the n plus 1 over n plus 1 plus c. You also have the integral of 1/x. Do not use the power rule here. You end up with an undefined result. So if you integrate that, this is a natural logarithm of the absolute value of x plus c. And the constant rule, the integral of a constant, is simply ax plus c. So these are the 3 formulas that we're going to be using for this example. Alright, let's go ahead and apply it. For the first one, we're going to be using the power rule. So we have 2 times x to the power plus 1 divided by power plus 1 plus 1/2 times x to the power plus 1. The power is 3/2, so we have 3/2 plus 1, which I can write as 2/2 to save time, divided by the power plus 1, plus 5. The integral of 1/x is ln x, so we have 5 times the natural logarithm of the absolute value of x, minus the integral of pi. The integral of pi is pi x, so we have pi x using this formula right here, plus c. Alright, let's go ahead and make our result look pretty. So we have 2x to the 6th over 6 plus 1/2 x to the 5/2 divided by 5/2 plus 5 times the natural logarithm of the absolute value of x minus pi x plus c. You can still simplify further. 2 goes here 1, 2 goes here 3 times. So that component becomes 1/3 x to the 6th power plus, you have 1/2 being divided by a fraction here, so you just drop change flip. You drop the 1/2 and multiply it by the reciprocal of 5/2, which is 2/5 x to the 5/2. And these last 2 terms have been simplified completely, so we'll just copy them down. To finish this off, we'll just simplify the middle term. So we have 1/3 x to the 6th power plus, these two 2's can divide out. 2 goes here 1, 2 goes here 1. So we have 1/5 x to the 5/2 minus 5 ln x plus c. Now this is one way you can write the answer. There's another format that you can write the answer in for the integral of y dx, which is writing this as a radical. So this problem can... Okay, so quick correction. We have, this is plus 5 ln absolute value of x minus pi x plus c. Left out part of my answer there. Okay, so this is one way you can write down the answer. Another way you can write it is 1/3 x to the 6th plus 1/5. This becomes the square root of x to the 5th power plus 5 ln absolute value of x minus pi x plus c. Okay, so those are two ways of writing it, either as a radical or rational exponent. Okay, so let's box our answer and write down what it means. What does this result mean? So write this down, meaning the derivative of 1/3, the answer, with respect to x is y. Okay, so this just illustrates the inverse relationship between derivative and integral. When you differentiate the integral, you end up with the original problem that you started with. So that's the meaning of the result we just got. So for part 3, we're to evaluate the limit. Evaluate the limit as x approaches 4 of y. Okay, so the limit as x approaches 4 of y, the original function, 2x to the 5th plus the square root of x to the 3rd over 2 plus 5 over x minus pi. So what does this function approach as x approaches 4? Let's go ahead and evaluate this limit. So whenever you're evaluating limits algebraically, the first line of attack is to substitute, right? So just substitute and hope you get a definitive answer. If not, you have to employ other means. Okay, so we're going to substitute. We have 2 times 4 to the 5th plus I can reverse the order of these operations. I can root the cube, or I can cube the root. Since 4 is a square, I'm going to cube the root. Okay, so I'm going to go square root of 4 first and then cube it. I can reverse the order, it's legal. Plus 2 plus 5 over 4 minus pi. Doesn't care what x does, it just stays pi because it's a constant. Okay, so let's work this out. 2 times 1000, 4 to the 5th power is 1024. Last time I checked, and if you multiply that by 2, you have 2048. You can verify that with your calculator. And then when you take the square root of 4 and you cube it, what do you get? Plus 4 plus 5 over 4 minus pi. When you combine these two numbers here, you get 2052 5/4 minus pi. If we want to write this as mixed numbers, multiply 2052 by 4 and add 5. If we want to write this as mixed numbers, it's going to be 8213 divided by 4 minus pi. Okay, so those are the two ways that you can write down the answer. So what does this answer mean? Let's write down the meaning. Meaning is as follows. As x approaches, let's rewrite what the problem says. Limit As x approaches its limiting value 4, y approaches 8,213 over 4 minus pi. So that's the meaning of the result we just got.